So yeah, she said I worked for a few projects in Go language, and I thought this would be a great opportunity to go over some basics. And since it is already a very popular language in just less than a decade, it's worth learning it. So let me share my screen. Okay, can you guys see it?
Yeah.
Thanks. So let's get started. We first we want to know what is Go language. The purpose of Go language was to start as a systems language, but it slowly digressed into becoming a general purpose language because of its usability and because of its ease of use and type safety. And the main goals of this language is that it has native support for most of the platforms, including ARM. Basically, you could compile a binary directly for an ARM architecture by just giving a flag. So, which is really cool for systems where we are, for example, developing a project on, say, Raspberry Pi. And another objective is that it is statically typed. Statically typed and dynamically typed means when you declare a variable, you have to explicitly give what type it is, like int, string, or and so on. And dynamically typed means that the type can be changed. The same variable can have different types. In statically typed languages, that is not possible. So if a variable is a string, it will always be a string. If it's a character, it will always be a character. So that is very important for the kind of goals that it had. Besides that, it has very lightweight syntax. It is in terms of syntax, it is very much comparable to Python. A lot of CS CS courses start with Python because it has very, like, the learning curve is very small. But it is an interpreted language, which makes it very difficult to be used for systems kind of an environment. So it has the Python and these languages have uses of their own. But why they're popular is that it is extremely easy to get started and build something using those languages, which is comparatively very difficult if you talk about C++, right? Hardly any people go for C++ when they're like starting out a course in computer science. Besides that, it has simple type system. So we're going to discuss this in detail in some time, what simple type system means. Basically, it means if the types can be easily inferred. Yeah, like that's most of it. And then concurrency primitives. What concurrency means is you're running a job parallelly or pseudo parallelly in a system. Um, Go takes advantage of the fact that most of the newer systems are multi-core systems, and it provides a very lightweight very lightweight primitives called Go routines, which is supported by the language natively, as against P threads or threads in C or you know threads in C++ or any other primitives in other languages. You have to use specific libraries, and if not, like Java has inherent support as well. But the synchronization and the worker pooling, it's a bit complex, basically. So keeping these things in mind, simplicity and efficiency, the language was introduced around 2009. Yeah, so it was earlier started as systems language, as I said earlier, for Google's internal systems. But in the first year itself, it gained popularity as the programming language of the year, which is a great feat. So we are going to talk about why that popularity. So as we spoke about simple type system. So simplicity does not mean that you have to make a choice between safety. A lot of languages, especially C++ and Java, they go by the principle that either you have speed or reliability or simplicity. Sometimes it's you can choose between two, or sometimes you can choose between just one. And these languages release features constantly to add more features, to make improvements. But Go stands by different principles. It The language has hardly added any features since its release. I mean, it has added, but the first release, that is 1.1, and the recent release, that is 1.15, have very few features in comparison. Like if those were the releases of some language such as C++ or Java, basically. So what it intends to do is you do not have to choose between simplicity and reliability. You can always have both, because you can based on the systems that are developed, like based on the modern systems, it is possible to do that, because C++ and Java were released a lot of decades ago, and yes, they are very efficient. um, but it's time to start from the ground zero and think if anything else is possible. And as I mentioned earlier, concurrent programming is very hard, but that again is primitively supported in Go language, and it is very easy to um, it's a very easy task for if the worker pool is like very simple. For example, some a basic HTTP server needs like a couple of threads. It takes hardly like 20 to 15 to 20 lines of code, and it's very simple to implement, basically. And why a new language? Because I just mentioned a few problems with C and C++. Specifically in systems programming, there has been research for like before Go was released, there was research for more than 2 decades. Um, excuse me, for having a new language which has type safety, and which is easier to it has easier concurrency and easier access to system level threads. So in C, the access between system level threads and user level threads has a lot of discrepancies. And by type safety, we mean if we declare a variable as, say, type char, right? We in dynamic programming, in dynamic languages, it is actually possible to change it. But since C is a static type language, it is not possible to change it, right? It's not possible by language specification, but it is definitely possible to change its type, like in a different thread or in a different like in a different function, by just calling it as a void pointer, right? If you pass a parameter as char star, and if you receive a parameter as void star, so basically that is changing its type. So that is guaranteed to be avoided in Go language. So if you pass a parameter as some value, say int or char, it always remains as int or char. This type safety is very important in low-level systems programming language, and it is like surprising that C, being such an old language, it still doesn't have those safety guards implemented. So yeah, even after those research, if anybody here is from operating systems background, you would have known like there were a lot of there were more than a couple of programming languages introduced in the research community, but no other language gained as much popularity as when Go language was released. Um, why the hype? So the most important part here is it is very easy to learn, and the second thing is in terms of efficiency, it comes very close to C and C++. Even the languages that were introduced in research, they have some disadvantages in terms of efficiency. If they are easier to use, if the concurrency is a major selling point, then efficiency might not be. So that is not the case in Go language. It comes very close to speed and efficiency to C++, and it's very easy to learn. Um, since the time Go was released, whenever you go to any learn like any new technology, they have like a page to get started. This is also like inspired by Java docs. So the language specification itself gives you enough resources to learn the language. So Go provides an interface called Playground, and it has a blog called A Tour of Go. If you just continue through the tour, you actually learn how to use Go routines, like which is a different name for threads. So I mean, it's that simple. So you like tutorials are very easy. Easy does not mean that like you have to not follow the language specification. That happens a lot of time when you're starting to learn something new. Um, so another important part is the formatting is enforced by language specification. So when you're exporting some types, right, exporting is possible only if the type name is in caps. So this is just one example that is enforced by language spec. There are other such simplicities like enforced, so that even if you are trying to learn and if you are bound to make mistakes, you really do not have any option to make mistakes. So yeah, another feature is that it has very fast build. It has really fast builds. So this is very important for enterprise systems. You're making some, even if you're making some minimal changes to an existing like legacy system, and if you're trying to rebuild it based on your tool chain, it is going to take you very long to actually get an output. Go is works in this direction that the tooling is extremely fast for these systems. Okay, I have a question, I think. Okay, sorry about that. Sorry, my system is a bit slow. So yeah, another selling point is garbage collection, the last point that we haven't discussed. So what garbage collection means is that if you are allocating some variables on the heap, in C it's done by malloc and calloc in C and C++. So in C you have to make sure that you deallocate the memory in order so that the system does not run out of memory basically. C++ provides garbage collection inherently, so does Java. This garbage collection makes these systems like it's an added overhead. So at every at every instance of like running after every stack instance, the stack is exhausted. The toolchain like checks through all the memory and like memory references, and like automatically frees the memory that is not being used anymore. So that is garbage collection. And as you can understand, this is a process which is clearly an overhead if you're considering very resource limited systems. But that is not true for Go language. It is garbage collected, but it is built in such a way that it does not affect efficiency. Um, which is why it was easily adopted for major systems like Kubernetes and Docker. So since the time, so who uses it? Since the time Go was released, within 2 years, it was like advertised as the language that is used for systems programming, because Kubernetes and Docker use it. But like now it's more than like it's almost a decade, and you will actually not find any enterprise which has any system software or infrastructure software and they do not use Go. Even the names that I have mentioned here are not extensive. So hopefully I have mentioned enough and explained enough to inspire you guys to start exploring it. This is one last comparison. So this graph is for this graph is, as you can see, if you have languages that are more efficient to run on the bare metal, they are very less efficient for humans to use. For example, C and C++. And languages such as Ruby, Python, Perl are very much efficient for developers to learn. That is why they are very popular for web development. But they cannot be used for bare metal. That is not the case for Go. In fact, the project that I did were running on a Raspberry Pi. So it is also efficient for humans, and it is near efficient for very resource limited systems. It is still not efficient for say microcontrollers. But even in embedded systems or other such applications, the trend is slowly migrating towards microprocessors or basically ARM-based systems. So, and which is why Go inherently compiles for a ARM binary. So yeah, and so let's get started with how we can start using the language. Since the time of this presentation is very limited, the things that we will discuss here are in no way extensive list of what the Go Lang's web page already provides. But we can have like a quick overview. So this is a basic hello world program. Package main is the name of the package or the name of the library in case you want to export. There has to be a package main in every project, no matter which file, and only the main.go can, or in any file can have just one package main. So the other files in the project will have the name of the project. For example, if the name of the project is say car, so every other files in the project will have package car, and one file where the function main is called, it will have the package main. So import is very easy, importing some libraries. FMT is for formatting library. It has printing and all that stuff. And main function just outputs format println. There is inherent support for the Unicode character set, which is, I think it's Unicode 32, not sure. But yeah, as you can see, there's inherent support, and you do not have to declare something else, like this is directly read as a string, and there is no semicolon as against Java and C++. So that is like a very good syntax candy. More basics, variables I was talking about before. You have to declare what the type is, or in case of the right hand side, the notation that you see colon equal to, that means that it is inferring the type. So both the ways are possible. You can like declare it as a var xy and like define its type, or you could directly say colon equal to and directly assign some data to it. So variables is declared like this, and control structure is just like any other language. But in this case, if you see, the control structure does not have brackets. But Go language has decided to keep the brace brackets for functions and such. Unlike Python, it doesn't use indentation to understand the function. It has to use braces. And structures, we will come to structures a little later. So these are the basics. If anyone has any questions, they can just stop me anytime and ask questions. Another thing is, this is what I was talking about. So as we saw in the earlier slide, we can always declare variables as var, name, and their type, or we could directly assign them values and the type will be inferred. For example, in case of pi, if we assign it as 3.142, it will be automatically inferred as a float type. Or if we assign a string, it will automatically be inferred as a string type, right? We can also assign directly a function to a variable. Functions are treated as any other variables. They are basically treated as first class citizens. So you could use functions as assignments, or you could assign them to different, like to another function basically, which is more or less like Python. Uh, and it is a huge advantage over C and C++. Right? And Go requires explicit returns, which means that you have to, this is very similar to C and C++. You have to return the variables. You have to name the variables that you're going to return. Like you cannot, like in case of other languages, the last returned value, the last calculated statement can be used as a return value, but that is not the case in Go. It's just you have to like write which variables are you returning. Also, as I said earlier, you could actually assign a function to another variable. So in case of this func main, res colon equal to plus is a function here that we have just described before this. And when we are passing this, so res is now a function, mind you, and we are passing res as a parameter to another function call. We are passing this as a parameter to println basically. So the return value, that is a plus b, 1 plus 2 is 3, will be printed on the console. So you automatically chopped off 3 lines in this, right? Because you directly passed a function to another function. Like you do not have to initialize another variable to collect the value of the function, like the return value of the function, and then pass that variable to another function to do some methods on it, right? So you could directly use this. Coming to structs, people who are from Java, Python background might not know what a struct is. So struct are basically, if you have ever heard of ADT or abstract data types, that's how that's why you use structs for. So structs can have um, uh, variables of different types. So in this case, name is a string and age is an int. So it is a collection of different types. And you can also return structs in terms of pointers. So in this case, when we are assigning person as name, we can also return the pointer to p, right? And if people are, if anybody here is from C background, if we return and p in say C, this runs in a stack stack overflow, because no, segmentation fault actually, because that memory address will not exceed outside of this function new person. But in this case, in Go, we can safely return the pointer to this person, because that pointer value is basically copied. Like, we do not have to go into those details, but in short, it is safe to return a pointer to a variable that was used inside one function. Okay. So Go has some design philosophies of how to make this language usable for object-oriented programming. But we'll just quickly go through some jargon so that we can understand what Go includes and what Go does not include. Right? So classes, objects, and instance. So the classes are objects are the basic building blocks, like as you can understand from object oriented programming. And object is simply a collection, uh, like uh, uh, like how you uh, translate a basic real world object into program. So an object always has some properties, and it can do some actions. So if, for example, if car is an object, it will have a lot of properties, maybe color. The most important property would be the source and destination, because the action that a car can perform is drive a distance from source to destination. Or an object could be cat. Cat has properties like its color, its fur, its color of eye, its eye colors, and its action could be it meows. So yeah, objects could be anything, but they're just a representation of real world instances. And as I described, these properties are called attributes, and the actions that the objects can perform are called methods. Attributes and methods are retained as it is in Go language, because they are very basic. We cannot do away with them. So this is about object, and class is a description of these objects, basically. Objects and instances is when, say, class could be a class cat, and an object could be, say, a particular cat. For example, Milky, or I don't know, somebody. So yeah, so an actual object or instance is dependent on how class is defined, basically. So when I say blueprint, you describe these properties. Say, in case of car, you describe these properties as color, model, source in a class, and what it can do, like driver distance, also like in a class. So this is about like very basic overview. In Go language, it is a bit different. Class is translated as interface, and objects are called types. Just naming difference. There's a lot of difference in implementation as well, and that difference is intended basically. We will see that later. But just to mention here, objects are called types, and classes are mentioned as interfaces. Inheritance. This is like the point of debate since the language was released. Any object-oriented programming, which is like an official object-oriented programming, will always have derived classes. Derived classes means there is some parent class which implements some methods, and a child class will basically have its own methods but derives some methods from the parent class. So as you can see in the diagram, if the parent class is a dog, the child class could be anything, a French bulldog or maybe a different breed of dog, just to make it like just a basic example. This inheritance leads to it is good when we think about object-oriented programming and how we want to simplify real-world tasks into a programming language. And it's basically one of the four major principles of object-oriented programming, which is encapsulation, abstraction, inheritance, and polymorphism. We will not go into polymorphism in this presentation. So why I'm discussing inheritance here is that Go specifically does not implement inheritance in its language. The way it says it is object oriented is that it calls it a composition. So what happens is the derived class will have some extra methods basically, and derived class can have another derived class, and there will be a chain of instances, which is maybe required in some cases, but this leads to a lot of confusion and a lot of added overhead, which is one of the reasons why object-oriented is rarely preferred for systems kind of a language. So yeah, we do not have inheritance in Go. It is implemented separately, which we will see in the upcoming slides. Is it clear till here, or is it going, everything is tangential? Because I just want to make sure this is a very basic tutorial, and I have left out a lot of low level details uh, to not make it confusing for the first time. Okay. Object-oriented programming in Go. So we discussed methods before. Methods are actions that an object can perform. It's the same in Go language as well. The way you describe method is you declare that inside it, you declare that outside the type. So you declare as function, and the type it uses, like the object it uses for that method basically. So in this case, type myFloat is an object, and function abs is the function. But when you say myFloat, then function is implemented over the type myFloat, and m is an object of myFloat over here. And mind you, when you declare function in Go language, you declare parameters inside. For example, in this ABS, if we had to input boundaries, then we would have input those boundaries inside ABS bracket, and the return type is immediately following the ABS, right? In this case, we are returning a float, so the return type is float. when you are declaring, when you are including anything before the function name, which means you are including the type name. So it means it's a method which is implemented over a type. That's how you differentiate between a regular function and a method over a type. Okay. And as I've mentioned here, Go objects are basically treated as values. I mentioned earlier that there are the design principles of this language requires that it is easier uh, to maintain the code as well. So there is no like a box. Basically, um, there are no hidden methods in this case. Okay, and you can define methods on any type. So if you okay, I haven't included the definition of my float. In this case, my float is just a float variable. It can have other parameters as well. You can use struct as a type here, and the struct can have float values, integer values, and string values. And the function which is built on that method can have like method which uses those values. Um, so basically it can be float, it can be struct, it can be string, it can be any type. As against what we had seen earlier, object is a specific definition which is defined by the class, which is the blueprint. So it has to be explicitly mentioned in the class, um, that what are the methods implemented, what are the attributes, and like what is hidden, like with what is public and private. In this case, we do have public and private. I mentioned a while ago that if you are exporting a method, it has to start with a capital letter. So in this case, if there is a package called float and you're exporting that package, you can import float in your program and use float.myfloat as a function from that package. If no, sorry, the function name is ABS. Sorry, my bad. So if you implement ABS in caps and you import a package called float, you could actually use float.abs in your program. And if ABS starts with a small a, it means it is hidden. It means that ABS is performing functions which are local to this specific type. Okay. And another detail, it's just a detail, maybe we do not have to go into that right now, but methods can be defined for pointer types as well as value types, right? Oh, I'm sorry, this should have been r star rect. I just wanted to mention that there it's possible that instead of like actual type, which is in this case, in the case of my float, we are using the type as it is, like as value. We could also use as func m star my float, or in the example and at the right hand side, I forgot to add the star here, but it could also be written as r star rect. So basically, it works on the pointer of the type, right? Coming to interfaces, um, as you can see, wherever we have discussed the type and the function, there is no like any blueprint given here. You just write the name of the type that you want to implement the method on, and just write your function. So how do we make sure like we have some blueprint? That is where interfaces come into picture. So in this case, uh, yeah, so in this case, we have an interface called geometry, and it has two methods in it. One is area and another is parameter. So in this interface, we haven't explicitly mentioned the types, the types over which it is like implemented. So the type could be circle, the type could be rectangle, the type could be triangle, and the triangle can have different properties, the circle can have different attributes, and the rectangle can have different attributes. But if they implement all the methods from this interface, then they satisfy this interface. In the next lines, I have mentioned function R and function over type R, which is a rectangle type, and it implements area, and function R, which is also a rectangle type, and it implements perimeter, right? um, it is also possible to have another type, say C as a circle, which also implements area and perimeter. To be qualified as a valid interface, you have to implement all the methods described in the interface. This is the difference between inheritance and composition. You cannot in inheritance it is okay if you actually you can have added sorry, in inheritance you can have added methods, but in this case you cannot. Like, you have all the area and perimeter, you are implementing it, but that is about it, right? And it is considered enough for the object oriented requirements of this language. You have to implement area and perimeter. You cannot not implement either of this method, and you cannot add more methods to the interface, basically. Yeah. And we can directly call methods in the named interface. No implements method means in many languages you have to specify what the class implements from the parent class or the actual class. So we do not have any such declaration, since the possibilities is actually reduced in this case. We directly call g dot area, g dot perimeter um, directly by its name. So there is no implements method here. Okay. Concurrency. Unfortunately, I cannot go into a lot of details, but concurrency is the major selling point of this language. Uh, it has go routines, channels, and buffered channels already implemented in its language specification. And we'll start with Go routines. Go routines are basically a translation of threads in many other languages, but they're not really threads. They can be thought of as a very lightweight version of threads. A single thread can have thousands of Go routines. It is that lightweight. And as I said, it's built in, and by default, Go routines are non-blocking. Uh, but if it is waiting on a channel, then it becomes blocking, because channels are by default blocking, right? Um, you can also multiplex Go routines, which I haven't gone into too much details here, but let's actually discuss the functions here. In this example, I have given two Go routines, timeout and read word. So timeout is another function defined somewhere. Uh, in case of threads, when you start a thread, you just call it, which is the same in Go as well. You call it, and the thread starts its implementation. And when you see T make channel, make chan stands for channel. These are channels that are passed. They are used to pass data between Go routines, right? So we have threads, which is good, but what now? Like, how do we pass data between those threads? So our answer is channels. Channels, we'll come into that in details. Um, just a detail mentioned here, it's similar to Erlang, uh, just a detail. So timeout and read word are started in parallel. If there is the read word in this case will actually wait on the main will actually wait on channel ch from read word. So read word is passing some data, and whenever that channel becomes ready, it is actually you know uh, detected by the select statement here. So based on whichever channel becomes ready, either from timeout, that is T, or from read word, which is ch, whichever becomes ready, that go routines execution is taken forward. Very simple. It doesn't even look like we are creating a thread, adding attributes, adding synchronization variables, 4 lines of code which is starting to go routines. Or it is not a thread, but just for the purpose of understanding, you can think of it as like a thread. Because as I said earlier, a single thread can still have thousands of go routines. Okay. Like thread, it has its own call stack, um, and it's not a thread. I have discussed these points in the earlier slide as well. We they're multiplexed dynamically, and yeah, we need to keep the routines running. Let's come to channels. Channels are for synchronization as well as communication. The communication part we just discussed. We created threads, okay, but how do we pass data between multiple threads? So our answer is channels. And synchronization, why synchronization? Um, because I mentioned there the operator arrow is used to send and receive values, right? So which is okay, but until and unless there is a value to send or receive, the statement, that channel will be blocking. It makes sure that the function following the receive or the send does not execute until and unless we have some value inside channel. If people with operating system background, um, they must realize this is very similar to mutex. Mutex is basically synchronization between two threads. If you use a mutex on a variable, you cannot go ahead until and unless one of the threads has finished working on the variable, right? Same for the receive. Both the receive and the send channel are by default blocking. There is another trick that I haven't that I specifically left out because it's a little bit complex. We call it as buffered channels. It's not that complex, but it might be too much to understand. So if we want to make this channel as non-blocking, we could use buffered channels. So in this case, the channel ch is an integer. Basically, we can pass one integer to and from. But in case of buffered channels, we could actually define a length. So for say 5, if we define a length as 5, so we could easily send and receive 5 integers with no blocking between two go routines, right? It is still synchronized. It is still good for synchronization, but let's not go into those details. And why it is mentioned, why the implementation is given in this way is because they have the efficiency, but the code that we are writing, right, we saw like we are not like we are not defining variables for using with the go routine. Like we're defining a channel, yes, but That's basically just 2 lines of code. It very much resembles like a synchronized, like a synchronous function, basically. And if you see, let's come back to this slide. So in this, in the first case, in the function compute, the channel is sending a value because some computation will obviously calculate some result, and it will send that value to channel ch. In the main function, the result is getting that value from channel, right? It's very easy if we look at the code to understand, like to understand what exactly is happening, which one is sending and which one is receiving. Um, Comparing this to the case of mutex in other languages, I'm very much familiar with C. So um, we have to have a section where we actually start a mutex and we decrement the mutex. So based on the value of mutex, if it is 1, then you can, you know, let the function execute. If it is 0, then it is blocking, which is very complex to understand in the first go. But in this code section, right, it's very easy. The main thread is receiving and the compute function is sending. Both are, in this case, it's a default channel, so it is blocking. Until and unless some computation sends a value to the channel, the main will wait for that channel. Very very straightforward, which is which I have mentioned in this slide as well. Um, and the basic philosophy of concurrency is that we have to share memory by communicating, but not communicate by sharing memory. So this means that we do not have memory overlaps between multiple Go routines, right? Like the communication happens. I mean, the memory share happens, but we are communicating by it, right? So this channel makes sure that the memory, that is some computation that is using, does not overlap in any case with the memory in the main function, right? In other implementations, if we have a thread, there is only one definition of that thread, and there are multiple instances of that thread, right? Based on which instance is called and based on what value of the mutex is inside that instance, that instance gets to access that variable, which means that variable comes into a critical section. Like that variable is shared between multiple threads. In this case, there is no such sharing. Whatever the variable is, that is like local to some computation, like the compute function, and whatever is, if you see, we are calculating the result of the channel in a different variable, that is result. So there is no memory overlap in this case, which is a huge advantage in terms of simplicity, and it does not affect the efficiency of the system in any way. This is exactly what we do in other systems too, um, but in a more complex way. Right? Um, Go also has a library called sync, which defines mutexes and other synchronization parameters. Because even if we have these cards available, some systems do require like low level access, and they need to know exactly what is happening. Um, I have not included example of sync.mutex, um, but this channel and go routines are like sufficient in a lot of examples of mutexes. Sure, we can have mutex, um, but for as I mentioned earlier, we could easily have a worker tool which is, say, we have an HTTP server handling multiple requests from clients. We could have just one Go routine that defines which incoming client is asking for resources, and we would not have to use anything from the sync library. This channels and Go routines is enough. We definitely do have complex enterprise systems where we need access to more routines. There is a case of generics as well, and other things, but let's keep it simple for the initial phase of learning. Actually, this is literally what I implemented for one of the API routing example that I had sometime implemented. Nothing besides channels. It's simpler and maintainable code. Basically, it's a major selling point, but it's much more than that. The point that it is simple and maintainable might sound like it's like an overstatement. But it's if we try to implement the same function in any other language, C++ and Go, we clearly see the difference. So let's stop here, and I've stopped with the list of resources that you could follow to learn Go in more depth. There's also a book which is I don't remember the name, but that book is released by the language authors themselves. But I don't recommend going by the book first. You have very good examples that you could start building your projects on. There's a website called Exorcism. I think I haven't linked it here, but I will send the PDF to the people present here and maybe send these resources. It's very useful to get started on. Right? Any questions?
That was a great presentation, Anjali. I really learned a lot. If anybody has any questions, please post it in the chat, or you can unmute yourself. And while everybody's, maybe if anybody's typing, what kind of projects do you suggest, Anjali, for anybody who is starting with Go? What kind of projects should we build?
Yeah, I'll come to that. I have a question on the chat. Did you self-teach yourself the language? Yes, I did. It is that is the whole that is a major selling point of this language. I mentioned in the slides as well the website called Tour of Go. It is by the Go language itself, and it is enough to get started. If you need like more in-depth examples, there is a website called Go by Example, also linked in the slides. They were the only things that I needed to refer to get started. And there is a website called Learn X and Y minutes. This is I think I sent. Yeah, so the website is like useful for basically any language reference. If you're from some, say, C++ background and you just want to try and just get started, it's a good website to just look at the code reference. And yeah, Divyanshi, you were asking projects to get started. The Go is a very it's a general purpose language, but the beauty of it and the efficiency of it comes together when we use it for like very systems purposes. One example, so by system specific, I mean, so example like URL shortener, right? It is very much based on string computations, or Another thing is that you could duplicate your command line programs that we use in Linux. For example, we use IP message, or we use any command line tool that we use. We use Telnet or iPerf, or whichever tool like you want to, try to learn. So these command line utilities are very easy to implement in Go. They literally take like 30 to 40 lines to build, because of there is another routine called flags, which are synonymous to signals in C and C++, which is also like very easier implementation in Go. So I would recommend command line tools, or URL shorteners, or projects related to, say, SQL. You could have like indexing project on SQL. So these things, they are very much concurrency specific, and you will be able to implement them very fast in Go.
Thank you for answering that.
Yeah, that's a good question.
So if you don't have any other questions, we can wait for a few minutes and then we can wrap up the session.
Okay.
Yeah. Thank you everybody who joined. This was the first time that we are hosting graduate webinars, and thank you, Anjali, for starting with such a high bar. And I'm sure the future graduate webinars will be as informative as this one. And we are really excited. And anybody who hasn't joined our Discord or Slack channels, please join us. And we have a lot of events. We host events every week, maybe every day of a week. We have a general meeting tomorrow. So please, if you have time, join us and get to know us more. Thank you, everybody.
Thanks, Divyanshi and the WinC team for giving me this opportunity, and I really liked giving this presentation. So yeah, thank you.
Thanks.